Dear students, today I am going to start a new topic, mathematical physics, that is ordinary differential equation. Okay, we have completed three topics for IIT JAM physics. First, we have completed about the single and multivariable calculus. Then we have completed vector calculus. Then we have completed Fourier series. Now we are going to start ordinary differential equation. And all the theory part I have completed. The topics that I have told, all the theory part I have completed with some solved example. Now we will solve some more examples as well as previous year question paper for these topics, and the video will be uploaded time by time. Okay, so please subscribe my channel to get the notification of these videos. And now I will discuss about ordinary differential equation, and then again I will solve more and more examples and also the previous year questions. So each and every topic will be going with this pattern. Okay, and if you see the videos, you can see the theory is the discussion of the theory is deep in concept. Okay, all the concepts will be very clear if you go through all the videos. Okay, you can go to the playlist and see the videos. Okay, so now let me discuss about ordinary differential equation. So the first question that can arise is, what is actually mean by differential equation? Okay, you know, in algebraic equation, and like if you talk about a algebraic equation like suppose x cube minus 3x square plus 2x plus 1 is equal to 0, this is the algebraic equation. This is the degree of 3. Okay, so this is the equation of degree 3. This is the polynomial equation of degree 3. So in this equation, you can if you want to solve this equation, you will get the value of x. Okay, and this is something like this kinds of equation, that is f of x is equal to 0. But here f of x is a polynomial function. So this kinds of equation you have already solved in your algebra, basic algebra. But now we will discuss about differential equation that involves derivatives. You might have studied this differential equation in your 10 plus 2 level, but let me start with from very basic. Okay, from very basic, and we will go up to the whole syllabus that we have in our IIT JAM physics. Okay, so we will cover each and every topics, so don't worry, please listen carefully and take note also. Okay, so ordinary differential equation. So differential equation means the equation which involve derivative. Okay, the equation which involve derivative is known as basically differential equation. Now this derivative may be of two kinds. One is partial derivative, maybe it is partial derivative, or maybe it is ordinary derivative. So if there is partial derivative, then that differential equation, if the equation involves partial derivative, then this differential equation is known as partial differential equation. Otherwise it is ordinary differential equation. But the partial differential equation is beyond the scope of our syllabus. This is the syllabus of csir neet. Okay, so we don't go through this portion, that is partial derivatives, but we will discuss about basically ordinary differential equation. Okay, which involves simple ordinary derivative, maybe the first order derivative, maybe the second order derivative, so that will involve. Now let me tell you why the physics student need to study this kinds of chapter of mathematics, this kinds of topic of mathematics, ordinary differential equation. There is a huge importance for physics students, because almost in each and every branch of physics we need to solve differential equation. And if you go through the very basic topics of mechanics, that is the fundamental topics of mechanics, that is the starting, you can say, that is starting of dynamics, that is the Newton's law. So if you study Newton's law, you can see the Newton's law is given by force is equal to mass into acceleration, F is equal to ma. This is basically a differential equation. Okay, because acceleration is the derivatives of 2 times derivatives of position. Okay, so you can write it in differential form, that F is equal to m into d2r upon dt square, where r is the position vector. So your equation will be something like this: d2r upon dt2 is equal to f by m. Okay, This, you can say, this is a set of equation. This is not a particular equation, a single equation. This is a set of equation, because set of differential equation, because this equation is written in the form of vector. But if you want, you can write it in component form also. So if you write it as x component, so you will get d2x dt2 plus is equal to, you can say, fx, x component of course, by m. Similarly, you can write y component d2y dt2 is equal to fy divided by m. Okay, so you can see how important this ordinary differential equation is. When our dynamics start, there is a very basic law of physics, F is equal to ma, which involves a second order differential equation. Okay, similarly, I can give you another example also from heat. Okay, so you know the rate of heat flow, that is dq upon dt, is equal to Ka, this is the thermal conductivity, into d theta upon dx. This is the temperature gradient. This is the temperature gradient. Temperature gradient. Okay, and this is dq upon dt, a rate of heat flow. Rate of heat flow with respect to time. Rate of heat flow with respect to time. So you can see here also the differential equation is involved. This is the first order differential equation. One is dq upon dt here involved, and d theta upon dx is also involved. And K is thermal conductivity, is the area of this conductor. Okay, heat conductor. Similarly, you can see these kinds of equation in electrical circuit also. Okay, so if you talk about some electrical circuit, something like this. Suppose, let me take RLC series circuit. Okay, so if you take the R, this is L, and this is C, and there is alternating voltage source A. Okay, and the current in this circuit is I. The R, inductor is L, and capacitance of this capacitor is C. Inductance is L. Now what is V? Okay, so V will be, you can write here also that V is here potential drop across this resistance is IR, plus the potential drop across this inductor, that is L di dt, and plus the potential drop across the capacitor, that is equal to Q by C. Okay, now if you differentiate again, then you can get, so that will be dV upon dt will be R into di dt, plus you can get L into d2I dt2, plus you will get 1 by C into dq upon dt. And this dq upon dt is again I, so you will get a second order differential equation of I. Okay, so if this can be converted, transferred to right hand side, and this can be written as a left hand side, so you will get this is L di d2I dt2 plus R di dt, plus I upon C is equal to dv upon dt. Okay, so this is a second order differential equation, you can see. Okay, this is another kinds of differential equation. So these kinds of differential equation will arise in physics here and there. Okay, so you can see in mechanics, you can see in heat, you can see in electrical circuit. So the differential equation is a very basic problems of physics. Almost in each and every topics, each and every branch of physics, there involve differential equation. So you need to understand how to solve differential equation, what are the rules for solving differential equation. Okay, so first what we will do, we will just study about linear differential equation. Okay, so you can see here, you can see one thing, that the equation that we have come across here, first one is d2r upon dt2 is equal to f by m. Second one, you can see dq upon dt is equal to ka into d theta upon dx, and we also see another one equation, that is L into d2I dt2 plus R into di dt plus I by C is equal to dV upon dt. So we have come across these three differential equations. Now this equation is the second order differential equation. This is first order differential equation, and this is again a second order differential equation. Second order differential equation. Okay, and the order of this differential equation, okay, will be given by the maximum order of differentiation. So here you can see in this equation the maximum order of differentiation involved is second order, so it is known as second order differential equation. Here you can see the maximum differentiation arise only first order, either dq upon dt or d theta upon dx, so it is first order. And here you can see there is first order differentiation as well as second order differentiation, so this is second order, because the order of the differentiation, the order of the differential equation, what will be the order of the differential equation, it will decided by the highest differentiation, the highest order of differentiation involved. So here the highest order is second order, here first order, here second order. And another one thing is there, the degree of this differential equation. So what is the degree of the differential equation, that will also decided by the highest order involved. And the power of the highest order, will decide what is the degree of this differential equation. And here the high power is 1, the power of highest order differentiation is 1, here also the power of highest order differentiation is 1, here also the power is 1. So all these three differential equations have degree 1, okay, have degree 1. So this is another thing that you need to know about the order and degree of the differential equation. And this degree can only be defined if the differential equation can be expressed as a polynomial, of this derivative. So I can give you an example, something like this. If you talk about this kinds of differential equation, like sine of dy by dx, suppose if you have sine of dy by dx plus d2y dx2 is equal to cos y, if you have this kind of differential equation, the degree is not defined, because this is not in the form of polynomial, this is a sine function, okay, and this is not in the form of polynomial. Similarly, if you talk about something like if ln is also involved, e to the power is involved, something like e to the power dy by dx is involved, if ln dy by dx is involved, then for this kinds of equation, this kinds of differential equation, degree is not defined. Okay, so we will see first order differential equation, we will solve actually first order differential equation as well as second order differential equation of degree 1 first, okay, and then we will solve also for degree 2 also. So first let me talk about degree 1, and then if degree is 1, then obviously it will be the linear differential equation. Okay, so let me define first what is mean by the linear differential equation, because we will first study about linear differential equation, then we will study about the nonlinear also. If time allows, we will discuss about nonlinear differential equation also. Actually here in this course, for IIT JAM course, nonlinear differential equation is not involved in the syllabus, okay, but if one or two kinds of problems are there, then I will solve also for nonlinear, but mainly we will focus on linear differential equation, okay. So let me define when the differential equation is called linear differential equation, okay. So let me tell you the general form of linear differential equation, okay. So what will be the general form of linear differential equation? Linear differential equation, okay. What is the general form of linear differential equation? So let me tell you, suppose a0y plus a1 y dash plus a2 y double dash plus a3 y triple dash plus dot dot equal to 0. Here y dash is meaning by dy by dx, y dash means dy by dx, and y means and y double dash means second order differentiation with respect to x. Okay, so if you want to write in this form, you can write this will be something like a0y plus a1 into dy by dx, okay, plus a2 into d2y dx2, this kinds of, okay, right, in this form. So when this equation, this differential equation is known as a linear differential equation, you can see the power of all the derivatives involved. Either it is second order, it is first order, it is third order. The power is always 1. The power is always 1. Okay, that means its degree is 1. Then it will call linear differential. But please keep in mind, it will depend on this coefficients also. So this a0, a1, a2, a3. If these coefficients are constant, actually these coefficients may be a constant. These coefficients may be of constant or function of x, or maybe function of x. Okay, and please keep in mind the power of y. Maybe it is y dash, maybe y double dash, maybe y triple dash, or maybe y also. The power should be 1, and the coefficient of this a0, a1, a2, this may be constant or may be function of x. Okay, if the power of dy by dx or d2 y dx2, all the derivatives and also y, if the power of these are 1, then only it is called linear differential equation. But this linear differential equation is also of two types. One is linear differential equation with constant coefficients, and another is variable coefficients. Okay, if a0, a1, a2, a3 are the function of x, then that differential equation is called the differential equation with variable coefficient. But first let me talk about the linear differential equation of constant coefficient. Okay, so let me before that, let me give you some example on nonlinear differential equation also, how the equation can be nonlinear and how the equations are looks like, how the nonlinear equations are looks like, you should know also. Okay, so let me take some example, something like y dash. Suppose y dash plus x y square is equal to 1, or you can say that something like y dash is equal to 1, this kinds of, or y dash square is equal to xy. You can see here the power of y or y dash, here also the power of y is minus 1. You can see y dash is equal to, you can see 1 upon y. Okay, so if the, because the coefficient of y dash cannot be, y, it should be a function of x. So if you move this y in this side, so it will be y to the power minus 1. So this is also nonlinear. So these equations are actually nonlinear differential equation. But you can see here the coefficient is x. So if these coefficients are, it may be of x or may be of constant. Okay, so so we first discussed about the constant coefficient, linear differential equation with constant coefficients. Okay, we'll discuss basically when we talk about the second order linear differential equation. But first let me talk about the first order differential equation. So we'll discuss about first order differential equation, then we will move to second order differential equation. Okay, so in first order differential equation, we will solve sometimes the problems involving the variable coefficients also. But for second order differential equation, basically we will move for the linear differential equation with constant coefficient. Okay, we'll see later on. Okay, so this is the thing that we want to know about this differential equation. This is enough for your introduction class, and from the next class we will discuss about basically the problems involving the variable separable. Okay, so first 2 or 3 classes that we will take about differential equation, you might have studied in your 10+2. Okay, thank you.